the equal groups. Don't have to be perfect, but you're going to do a group activity. 4 groups total. So you can, if you feel like counting off by 4s, you can, but if you'd like to be with your friends or whatever, that's fine. Just get in 4 groups. There we go. Okay, so we're going to talk today about risk analysis. How many of you have done an FMEA for your team already? Ooh, nobody. Good. Then you've got plenty of chance to learn. How many of you have heard of an FMEA? Ooh, a few. That's better than none. Okay. So we're going to talk about risk analysis today. If my clicker will work. I guess I got too far away. And we're going to use this 4-letter acronym about 1 million times. Right here, FMEA. Okay. That's failure modes and effect analysis. All right. Those of you who go into industry will do a lot of this, really regardless of what role you do. And this is basically a systematic way to make sure that you don't screw up. Okay. That doesn't mean that you can't mess up or have an unsafe product. They happen all the time. So you think about the Samsung phones exploding. They did lots of FMEAs on those. They didn't see that one. Right? If you make enough of a product, eventually you're going to have things that you couldn't have tested for. Right? So you think about a lot of the 1-800 bad drug kind of things. They test those drugs over and over and over and over. Right? But you can't test, say, 100 million people, and then you get 100 million people on the drug, you start to see effects you didn't expect. So it's not perfect, certainly not perfect. But it's one of the good tools that we have to try and make sure that we are considering all the effects that could happen when we design something and we build it and put it out in the real world. So we're going to talk about what the heck is an FMEA. We'll talk about how you go about doing one, when you should do one, and that's a tricky point. Most of you, since you hadn't raised your hand that you've done one, are too late, so you should have done it already. That's something that we don't teach very well, my team's included. We oftentimes don't start those until later on in the design process, where when I was in industry, we would start them right at the beginning. Okay, so as soon as you had a concept, we would get into it, and then we would update them as we go. And then some of the how. So I apparently can't walk this far away. Here we go. Oh, now I got 3 of them. Did I get it? Yeah. So an FMEA is just a step-by-step approach for trying to identify all the possible failures in a product, figuring out what will happen when those failures occur, and trying to figure out ways that we can mitigate those failures. Okay, so we can try and prevent them from happening or reduce the impact when they do happen. So FMEA is failure modes and effects analysis. So the first part, failure modes, are simply ways that a thing can fail, right? So that's very vague terminology on purpose because there's a lot of different things that can happen in all the different products that you can make. So usually we'll start with a design FMEA. You may hear it called a DFMEA. So this is looking, most of what you guys do is going to be from this level, right? We're in the design phase based on the design decisions that we make along the way. What could go wrong with our product or our project? But you can come through and do these again in manufacturing. So you say, during the production of this part, what could go wrong, right? Could I jam a machine and tear up $1 million machine? Could I have a delay in production that could cost my company money? So there are a lot of different risks. And we think of risks as safety problems. And that's a really big part of it, but that's not all of it at all. So an example of that I like to use, how many of you have heard of the company SanDisk? Right, a lot of you? So you make like little SD cards, right? So what would you think if your little SD card, say, every time it got below 32 degrees outside Fahrenheit, it erased, right? Would you keep buying those SD cards from SanDisk? No, right? So that would be a huge risk to their company, right? If all of a sudden they had a winter hit and their whole new product line erased everyone's data, right? That would be bad. And that would be a big risk to their business because their business is based on trust, right? You trust that little card not to lose your, all the pictures for your family or your homework or whatever it might be. So you can have risks with your product that don't have anything to do with safety, right? No one got hurt. But it could be a business risk. There are a lot of different things like that. Another very good example that comes up a lot when you think about manufacturing ones are delays in delivery. So if you have a product and every month of delay costs a certain number of millions of dollars, that delay can be a big deal to your company, right? It could end up having people laid off. You could have factories close, things like that, because you as a designer delayed manufacturing, okay? So you want to account for all those risks up front. So those are some of the kind of failure modes. You especially look in our case at ones that affect our project partners, right? So we're looking at what could happen with this device for our project partners. So again, safety is obvious, right? You're making a display for Imagination Station downtown. If it's going to electrocute some kid, that's bad, right? Those are pretty obvious ones, but those are very important ones. But likewise, if you had, say, some offensive terminology in a display that you had and you weren't aware of that, that could cause them problems as well, because they could get complaints, things like that. Make sense to everybody? So a lot of different risks, and how you're going to rate those risks depends on your project. Is really contextual to what you're doing. Okay, so even for your one project, you may do a couple of different kinds of risk analysis, different FMEAs, with a different context or scope to try and figure out, okay, in the context of how it's going to affect my partner, it's on this scale, on safety, it's on this scale, so that you can consider those things separately. You guys are just a little bit late. So then the last bit is effects analysis. So effects analysis is, okay, something went wrong, what happened, right? What's the severity of the outcome? Is it just that my project is late for a week and my project partner is upset with me, or is it that kid gets electrocuted and that's a big problem, right? So you're gonna look at those and you're gonna set them in the context of your specific analysis. So a 10 out of 10 severity on one FMEA doesn't match a 10 out of 10 on another. It's not an absolute scale. You have to scale it to the problem that you have at hand, okay? So that's something that you'll want to communicate in your FMEA. Again, I have to walk back here. Come on. So these are probably pretty obvious, but why perform? So first of all, prevent injuries. That's going to be the biggest one that you guys all have. You want to eliminate those kind of things where you're going to do a biodigester in South Africa and it could explode if you build up too much gas in it or something. You want to prevent those kind of immediate safety hazards. You want to prevent product failure. So if you're going to put something out in the field with your project partner, you don't want it coming back in a few months. This is one of the ways that you can put it through the rigor to say, I'm confident when I put this out in the field that it's not going to fail, right? It's going to be a successful product. So a lot of you who were here last week, we talked about doing tolerance analysis on an assembly, right, that's done in the field. That is one way to limit risk in the field, right? So here you're going to look at broader at all the risks that could happen, and then reduce business risk, and we've talked about those, late products, things like that can cause a risk to your business. So going forward, when to use it. I talked about this a little bit earlier. You really want to start doing your FMEA for your project as soon as you have a conceptual design. So as soon as you have a general notion as to what you're going to build, you'll start to see risks. So if you think about, if I asked you for a problem to create a boat, right away you'd start to think about, okay, it can't sink, it can't, even though you haven't begun to think about what the actual design of your boat would be, right? So you can think about some of those risks immediately as soon as you have a broad concept in mind. But then the more detailed you get through the design process, the more specific those things will become, right? So in the beginning, you may say, my boat can't sink. And by the time you get to the end, you may say, this particular member in the frame can't fail during a storm with a swell of a certain amount. So just like we went from user needs being really broad, where it was like my car should go, to being my car should go 0 to 60 in 12 seconds, right? So we get more specific. These get more specific as well, okay? So you're going to start out, I don't want my boat to sink. You're going to end up with an analysis of every member that makes up that boat, okay? So you get into those details. Get down in the weeds on them as you go along. And they're really driven by your specifications. So just like our user needs were broad and our specifications were specific, every one of my specifications can have specific risks that I tie to them, okay? So the first thing I usually do with these, I write my user needs list, okay? And then I get a specifications list. This is pretty early on in the project. And as soon as I have that specifications list, for each specification, I can start to write down hazards, right? So what could go wrong? All right, so I went 0 to 60 in 12 seconds. What could possibly bad happen, right? A lot. But you can start to get to those in that early phase of your project. So if you table them out that way, you start with user needs. Under each user need, you have a series of specifications. Under each specification, you can have a series of risks. Then you'll cascade, and you can see how all of the decisions you make cascade into those risks. And then when you go back to test at the end, you can say, okay, I'm going to do validation and verification based on the risks that I found in my FMEA. These are a very good thing to do before you make a change to a project. So say you had something out in the field, it didn't work, something went wrong, then you know you need to add those things back in, right? So if you have a product failure or complaints from the field on a project, you can add those things back in, figure out why didn't we account for this? What do we need to do to make sure this doesn't happen? So again, that Samsung phone is a very good example, right? You got phones exploding and out in the field, and they're going around saying, how did we miss this? What went wrong? What caused this? And they went through a few different guesses of what the root problem is, right? So they've had to update that as they went along, and the engineers are playing some guessing games because they missed on their FMEA in the beginning, right? Very common problem. Like I say, as you scale something up, you're going to have problems you didn't anticipate. Your job doing an FMEA is to do your best to anticipate. So these are typically a team-driven activity. So as you go forward and you're doing project management out in an industry or in your projects here, you're going to say, okay, let's get our whole team together so we can get diverse perspectives, people who will see this from different points of view, and they'll be able to pick out different risks, right? So somebody who specializes in marketing or sales will have a different point of view than somebody who's in operations and delivery planning. So you'll be able to get all of those people together in the room and say, okay, what all could happen with this project from start to finish, okay? Within the scope of the analysis you're doing. So typically in medical device industry where I came from, you're required to do these. I think it's like 1 year, 5 years, 10 years, something. There's a schedule out from when you do the project, where here in the United States, the FDA will expect you to turn in a review of your own product where you're going to look at, here's all of the complaints we've had from the field, here are all of the recall information, everything that's happened, here's all of the risks that we knew in the beginning and everything we know now. Okay, so you want to update these as you go. So in EPICS, if you're working on a project that's been out in the field and come back, you want to come back and update your risk assessment to add all those things in that you didn't know about until it was out in the field and you got some information. And then obviously when failures occur. So anytime something goes wrong with your project or your product, you didn't anticipate that in your original risk analysis, you're going to want to update your risk analysis to include it. This is kind of fun having I don't know, my batteries are dead or something. Let's keep walking back over here. So we'll go through some examples in detail. I'll show you some tools. But the main thing that comes out of a risk analysis is a risk priority number, or an RPN score. And you'll see these a lot when you go into manufacturing. And they simply look at the severity. So this was the risk, right? What's the severity of the risk? What happens? Does someone die, or does someone get a paper cut? Does it cost their business $10 million or $100, right? So this is where you're going to look at the risk. What's the severity? You're going to look at the occurrence. So how likely is this to happen, right? So say the outcome of this hazard is death, but it's less than 1 in a billion likely to happen. Or is it, the severity is it's going to cost our company $10,000, but it's definitely going to happen, okay? So you want to look at the occurrence, and you'll give those a scale. And you'll create that scale based on the information that you know, okay? A lot of times in templates, they'll say between 1 and 10, between 10 and 100, between 100 and 1,000, between 1,000 and 10,000. What's the likelihood that this occurs? Those can be useful, but typically you would have to run a lot of testing to get hard data on what those are. So in the context of your EPICS projects, you're probably not going to run testing to that level unless your risk warrants it, right? So if the severity is high, you'll want to know for sure what your occurrence is. If your severity is low, you may be willing to take an educated guess based on experience or an expert opinion. You could talk to your advisor and try and think what that score is. So if you end up with a list of 1,000 risks, we don't expect you to run 1,000 tests to determine what the occurrence would be, right? Because you don't know until you've done some testing. We expect you to use your intuition, talk to experts, use your experience, okay? Only if that risk is high would we expect you to go back and test. And that's true in industry as well, okay? So you're going to justify those scores to yourself. So you usually should be your own harshest critic on these things, right? Do I really know what I'm talking about? Have I really controlled this risk? So you want to be able to sleep at night knowing that you've taken care of these things. So a lot of times we'd say, would you trust this product if I gave it to your mother, right? So you want to believe that this thing is safe and it's not going to hurt them. So the risk priority number is simply the multiplication of severity, occurrence, and detection. Detection is probably the trickiest one, the one that people get wrong the most. So this, you're looking at how likely are we to catch this thing that it was going to happen before it actually happens, right? So you say, I'm doing a bridge, the risk is that the bridge collapses. The detection isn't would I notice that the bridge collapsed, it's would I notice that it was going to happen before it happened, right? Could I reduce the severity because I knew it was going to happen? Does that make sense to everybody? So you say, the bridge may collapse with this occurrence, but I'll know it's going to happen a month in advance and we can get everybody off the bridge or support it, right? Where if your detection, it's not, can I see it after the fact? Is that clear? So a lot of times people get that one wrong. Like, oh, you would obviously notice that it happened. Well, that's not really what we mean. We mean, could you notice that it happened and prevent the bad outcome, okay? So your RPN is just the multiplication of those. So a lot of times people will do each of these on a 0 to 10 scale. So your worst possible score is 0 and your best possible score is the other way around. Best possible score is 0, worst possible score is 1,000, right? 10 times 10 times 10. But you can apply whatever scale you want that makes sense in your situation. But when talking to other people, they may expect to that scale. So if you don't use a 0 to 10 for each of those three, just make sure you explain that in your documentation. Okay, so procedure for doing this. I'm going to walk you through a website from the American Society for Quality, or ASQ. I'm going to show you they have got a big toolbox with a lot of things that you can use, both here and as you go on in your career. So if you need templates, American Society for Quality is one of the really large quality societies that look at mostly quality engineering. So how do you make sure that products meet the specifications? That's really what quality engineers are all about. And this is a large association of them. So I'll show you some of their tools and we'll walk you through their template. Then I'll give you a little bit of time for an activity. So it's asq.org. It's a tough one to remember. This is their website. So American Society for Quality, people who are passionate about quality and tools for quality. So if you come to the Knowledge Center, which if you can see my mouse up here is the top left one, there are a lot of tools in here. So what I would go to is Tools, which is the second box, and then View All. Now a lot of the things that we talk, let me see if I can make this bigger for you. A lot of the things that we talk about here in EPICS have templates here that can help you. Most of you, or all of you, should recognize a Gantt chart. We can come through and do a lot of things like a cause and effect Ishikawa fishbone diagram. Some of your teams will have done those. You can look at a number of different things, but the main one that we're going to look at is the FMEA page right here. There are two links. One is the page that actually describes the FMEA, and the other one is the template. So we'll start here. And if you go to do one of these and you don't remember everything we talked about today, or you need more detail or clarification, this is a great place to go. These are pretty good instructions, even though they're presented sort of in paragraph form, which isn't the most interesting thing. But you can get some of the different things you might hear are effects and criticality analysis. And you see that a lot too, FMECA. People call it a FMEA. So if you move on here in industry and you hear somebody say, we need to do a FMEA or a PFMEA or a FEMA or PFEMA or DFEMA, these are all variants of the same thing. So the P would be process, the D is design. Sometimes they put in the C, sometimes they don't. The C is just criticality, so how important is it? But a very similar mode of doing an analysis. And you're looking at the consequence of failures. So that's the effect part again. It gives you a little bit of history. These were started by the US military, really heavily used by places like NASA, government organizations, and in industry. But the basic procedure, like I said, you are going to, one, create a cross-functional team. You want to bring people in from as many different walks of industry, different walks of life in this case as you can. So people from different majors, people with different roles in your team, because they're going to have different viewpoints of what might fail. So like we talked about, if you're looking at a business risk, someone who's in operations and looks at how do we stack up different procedures to be done in a factory, they're going to have a different worldview, a different set of risks than someone who's on sales would have, right? So your person who's out in the field with customers, they're going to have a different viewpoint. You as the designer might have a different viewpoint. So you want to bring all those people together in a cross-functional team. The more different viewpoints you have, the more risks you'll identify. The more risks you identify, the more complete your analysis will be. You'll identify the scope. Okay, that's really important. So you want to scope your analysis to what's relevant to your project, right? So if you're thinking about business risks, scope it to those. If you're thinking about health effects, scope it to those. You want to try and limit those things. Sometimes you can do it broadly, but it depends on the complexity of your project, right? If you have a pretty simple project, you can probably do one and include most of these things in one analysis. But you want to be clear about what that scope is so that people can understand. If you're really looking at business effects, but there are health effects and you don't talk about those, people will be like, you completely ignored a lot of important things. Say, that's in a different analysis, okay? So be clear about that. You want to identify this documentation so that people can read it later. And then for each, you're gonna list functions of your project, okay? So this is when I say it's driven by specification, that's the terminology they're using here. So we say user needs are the big functions, specifications are the quantitative functions, right? So we gave them more specific information. So for each of those, you're gonna look at ways that failure can happen. Those are your failure modes. So mode is just a way, right? And then you look at the severity of each effect, how serious is it? So 1 to 10 scale is pretty normal. And then for each one, you're going to determine all of the root causes, okay? So say the bridge collapsed was my risk. You're going to say what caused it to collapse, right? Was it an overload of a beam? Was it too much traffic on it? And was it too high of wind shear? You want to look at all of those different modes or causes for that failure to occur. And then for each of those, you'll identify those several things: severity, occurrence, and detection, right? And that'll give you an RPN score, which is simple multiplication. You guys can do that. And then, so you get that, and then you'll identify recommended actions. So the last piece of this is, I have an RPN score, right? Say it's 0 to 1,000. I'm going to set some threshold and say if my score is above 100, that's too high. And so I'm going to say if I have a score above 100, I want to do something to mitigate that score. So I want to lower my occurrence, lower my severity, or improve my detection, okay? So this is how you say, in the beginning of my project, I went through and analyzed these risks, right? Without controls on them, or with current controls, right? What exists now? And I said, these risks were too high. So I'm going to do some amount of mitigation. I'm going to do something to limit those risks, right? So we said, I had this risk that if I have too many cars on the bridge will collapse. So I'm going to mitigate that by strengthening the weakest members in the bridge, right? I'm going to, by design, reduce the probability of that happening, and that's going to give me a lower occurrence, right? So typically your severity doesn't change, right? If the bridge collapses, everyone on the bridge dies, and there's a significant interruption to transportation through an area, right? The severity doesn't typically drop, but you can drop the occurrence or you can increase the detection. Does that make sense? Okay. So as you go through and do these, you look and be like, we need to reduce this risk. What do we do? Very rarely can you intervene on the severity, right? If it's a big deal, it's a big deal. So as you go through and do those, you'll do recommended actions, and then you'll calculate a new RPN based on the changes that occurred from that. Okay? All right. So I'll show you an example here. Hopefully I can blow this up. All right, is that legible back there? Sort of? This is why I want you guys to sit in the front middle, remember? There's a lot of seats up here. Okay, so this is a quick FMEA on an ATM machine. So you can think about a function of that machine would be to dispense an amount of money requested. Okay, that makes sense to everybody, right? That's one of the basic functions. So this is something we'd look at a user need level. The potential failure modes could be it doesn't dispense enough money, it dispenses too much money, it takes too long. Right? These are some of the problems that could occur with an ATM machine giving you money. Right? And then for each of those potential failure modes, you'll have a list of effects. Right? So you can have more than one failure mode for a given function. You can have more than one effect of that failure for each mode. Okay? Everybody follow that? So we said it's going to dispense the amount of money. First failure mode would be it doesn't dispense the cash. And your effects could be your customers are very dissatisfied, right? I went up and put my card in, typed in my PIN code, said I wanted $50 and nothing came out, right? That's not good. It could be an incorrect entry to demand into the deposit system, right? So if you came in and you tried to retrieve money, it says you retrieved it, but it didn't give it to you. Now you've thrown all of your accounting off, that's a problem. Or it could be a discrepancy in the cash balancing. So you have all these different effects from what happened. So you'll give that a severity. So in this case, they see severity of 8. Now, did anyone die from this? Did anyone lose a limb? No, right? But in the context of this analysis, that's a high severity. When I came from medical device, and 8 was a permanent impairment, okay? So that was like, I worked in knees, okay? So that was like we had to cut the top of your femur off, right? And 8 was a different level of seriousness than this 8. But to someone designing an ATM, this is a really bad failure, okay? So this is why I say you have to scope these to your specific situation. So probably most of your projects, the outcomes aren't that bad, right? So say you're doing an educational display, the risk may be that the person interacting with it didn't learn, and that may be a really big failure in your situation, right? But again, if you're on, say, the biogas digester team, you could cause that thing to explode and send somebody across the village, right? That's a bigger failure, but your risk number may be the same based on the context of your problem. So they give this a high severity, and then for that effect, they have the causes of failure. So it could be it's out of cache, could be machine jam, it could be a power failure. These are the reasons why it happened. And then you have an occurrence for each of those, okay? So how likely is it that the machine ran out of cache? They give that a 5. They say it's pretty likely that you at some point run out of cache in the machine, okay? Could be machine jam, that could be less likely, a power failure even less likely. So here you're looking at how likely are these things to occur. You look at your current controls. So this is without adding new controls. That's why I said we're going to look at current controls and then mitigating factors. For most of you in your projects, you have no current controls, okay? So it's not being flipped. Most of the time when you're doing a project like yours, there aren't existing process controls, okay? Because you're not redesigning a project that exists or a product that exists. You're not doing a line extension. You're creating something brand new. So you probably don't have any controls. So you'll say, okay, well, here's my detection. Here's how likely we are to see this. So maybe on being out of cache, we'll have a low cache alert. This is going to let someone who runs this ATM know to refill it. And there'll be a detection along with those, okay? So there'd be internal jam or none. So say a machine jam, you may have an alert, but they give that a detection of 10, which means it won't be detected. Even though the machine may sense that it happened, you can't prevent it in advance, right? So it's just saying, I jammed. It doesn't say, I think I'm jamming, I'll try again. So that's why they give it a 10. So that's a little bit tricky, right? A high detection is a bad thing. That sounds backward. It's like detection is really like not detection, or it's like an inverse of detection. So then they simply multiply the severity, the occurrence, and the detection to get the RPN score. So 8, 5, and 5 was 200, or you had 8, 2, and 10 was 160. So you get that ranking of how serious are these things to us. So if we had set our threshold at 200, we said we don't need to do anything. Below 200, we'll accept that risk. Then we don't need to do anything about power failure, but we do need to have some kind of mitigation to the being out of cache or machine jam. Okay, does that make sense? So you may go back through, under recommended actions, you may say we're going to create a anti-jam system to drop that occurrence, or we may have a jam detector that will see that it's going to jam, pull the money back and try again, something like that, right? So there are two ways you could go about it. You could try and make it more detectable so that you can detect it and correct it, or you may try and make it less likely to happen. But in none of those cases do you really change the severity, right? There's not really a lot of controls you can do to say, okay, it won't be a big deal. That make sense to everybody? Okay. All right. So again, you've taken some action. You're going to get a new SOD number to get the RPN. All right. So that'll give you a fresh RPN after you've done your change. Right. So we say we're going to do a redesign. We're going to do some kind of control measure. And then we'll get a new set of scores after that control measure, and that'll be our new RPN. So this is where you can look at this chart and say, we considered all of these factors, here's the ones we thought were serious, and here's the ones that we corrected.